Good. Okay, so if you have any question from the previous discussion, you may ask. Otherwise, we'll proceed to the more of the function study. Okay. Any question? Chale. If not, let's start with reviewing the basic things. How did we define a function? So there were two levels of definition of function. One was the actual definition, the abstract one. Okay. Abstract one, that a function f is basically a subset of the cross product of two sets. Okay. But it's kind of a subset such that it satisfies two properties. Number one, that for every a in A, there is a b in B such that A is related with B through this relation f actually. Okay. And that B, this B that exists for every A it must be unique as well. In other words, for any A in A, if A is in relationship with B and A is also in relationship with B prime, then B and B prime must be same actually. Okay, then B and B prime must be same. This was really the abstract definition of function. Then we say that f is a function from A to B. Okay, and then we denote that function by notation this actually. So this is really the notation. That's a shortcut to say, or that's a symbol to say that f is a function from A into B in the above sense actually that I have described here. Okay. And the notation for that A and B are in relationship f is same as that B is equal to f of A. So rather than writing this, we will often write this actually. Okay. Hence, we may define function in another manner, that we would say that there is another way to put the definition of the function, that f from A to B is a function, okay, if for every A in A, there is a unique B in B such that B is equal to f of A. Okay, B is equal to f of A. So this is really, so this description of the function is really the cryptic way. Okay, so this is really a cryptic way. Okay, so it's like a, not an explanatory way, but it's a cryptic way to way to say the above definition. So we are precisely saying this, but with this notation, okay, we can re-say the above definition in a more popular fashion actually. So this is the kind of more popular fashion, that a function is an association, it's a mapping, it's a, you know, assignment, such that it assigns every A to a unique B in B. Okay. So this was the definition of the function. And then we also define what do you call one-to-one function or one-one or injective function. Okay. And we reached to this definition after an analysis actually. Okay. So the definition that I'm writing, it's not coming out of, you know, somewhere. Okay. It's a, you know, it's out, you know, nowhere actually. So it is coming out of somewhere actually. So we had a discussion, long discussion, that why a function from A to B is 1, 1 or injective if for any A and A prime from A such that their images are equal implies that the inputs are equal actually. Okay. So that if the images of, you know, of A and A prime are equal, then A and A must be equal. So if a function has this additional property, then you call such function as the 1, 1 function actually. Okay. And we saw actually that like this guy is a contrapositive basically of the popular definition that, okay, if the inputs are different, then the outputs are going to be different actually, right? So this one is kind of distinct elements. Distinct elements have distinct images, but you can also rewrite this statement in its contrapositive form, which is easy to verify. And then we did several examples of all this as well actually. Okay. So what we would like to do today, we would like to talk about onto functions. Okay. So this is what we're gonna do. We're gonna talk about bijections. Okay. We're gonna talk about composition and inverses of the function. Okay. Of function, and probably we will also talk about that, you know, how all these functions can give you the exciting conclusions about the cardinalities of set of natural numbers, rational numbers, and real numbers, etc. Okay. So that's what is the agenda. It's a pretty long agenda for today, actually. So let's start. So is there a question from, you know, this previous discussion? Okay, so it seems there is no question. So let's start with, what do you mean by an onto function? Onto function, and it's also sometimes called surjective function, or simply surjection. Okay, all these are the names for the, you know, onto function. So what is the definition that you have for the onto function? Anyone? when a function is onto. No one? Challenge. So here's the definition. And the definition is simple. A function f from a set A to B is onto, okay, just for a second. Okay, so a function from f to f from A to B is onto as adjective if it satisfies an interesting and a simple condition actually. And that simple condition is that f of not f of A, but the range of the function f is equal to the codomain of the function actually. Okay, the range of the function A is equal to the codomain of the function. So if you have such a function, you call that function as the codomain function, as the onto function. Okay. So for example, we can start with say this typical example that okay, you have this physics and maths and English books, and you have these prices 10, 20, 30. Okay, then this function is onto if okay, E. So it's onto if the range of this function is same as the codomain. So this is set A and this is set B, and say the price of the physics book is 20 and this is 30 and this is what do you call 10 and 30. Okay. Now what is the range of f? So the range of f is really f of p, f of m, and f of e. Just apply the f onto the entire domain actually. Okay, and see what you get. So f of p is 10, 20, and 30, which is same as the codomain. So you're gonna say that hence f is what? F is onto actually. Okay. But interestingly, this function is not only a function, but this function is also 1, 1 actually. Okay. So it's also 1, 1. Okay. So different elements of the domain have different images actually. Okay. They have different images. So it's all to 1, 1 function actually. Can you think of an example of f which is onto but not 1, 1? Any example? What should I change in this function so that this function, okay, becomes onto but not 1, 1? At the moment, it's 1, 1 and onto both. So क्या करना चाहिए? What should be done?
सर बी के एलिमेंट को 2 बार मैपिंग करूं एक को
That's one way to do it. That lets to A, B, okay, and so you have this P, M, E, and 10, 20, 30. Okay. If I say that, okay, P is mapped onto 10 and M is also mapped onto 10 and E is mapped onto 20. Okay, so you're gonna say that this is, no, this is not an onto function. This is not even an onto function. So you can treat this example as the example which is neither one nor onto it. Okay, but I want a function. Okay, ये तो फिर आपकी suggestion, your suggestion didn't work actually, which is which must be onto but not one. So one thing that can be done,
Sir, constant function can be.
a constant function can be, yes. So a constant function can be, or you can also think Pm, say E, okay, and say 10, 20, and 30, and maybe let's put biology actually. Okay. So one thing that you can interestingly observe is that now in order to make a function, I have to give P some value, M some value, E some value, but I have to give also B some value. Okay, so let's assign B to the 30. Now this function is onto because all elements in the domain have some preimage. Yeah, the range is same as what do you call um, the range is same as codomain. Okay, so this function is onto but not, what do you call, one. Okay, it's onto but not one. So you can actually see an interesting conclusion, and we will talk about that conclusion later, that one and onto function. So if you have a one function between two sets A and B, and if you have an onto function between two sets A and B, it tells you something interesting. Okay, so if a function is one, so let's talk about later actually. Okay, when we'll talk about cardinality, but that's what is really, the simple way to say that, okay, some functions, when a function is one and not two. So that's a simple example. But but imagine if I have been given a genuine function f from R to R, and I have been said that verify that f of x equal to, say, 3x plus 2, or f of x equal to e to the x, they are onto functions. Or are they onto functions? So how can I verify such a function actually, that whether a given recipe of a function defines an onto function or not? Okay, I know that, if I have been given a function in such a form, I can quickly see the range and codomain, and I can say that whether they are equal or not. But if I have been given such a function, okay, then how can I verify, um, you know, how can I verify that whether a given function is onto? Okay, then this definition is going to be helpful. Let's drive a criteria. Okay, let's drive a criteria for surjectivity or ontoness, or ontoness. Okay, in other words, if I give you a function, how can I know that the given function is onto or not? Okay, so if you have been given a complicated function, it's pretty simple in case of the simple functions, but in case of the complicated functions, okay, like functions that are defined on some infinite sets actually, how can I know that um, a function is onto? So the definition is same actually, that okay, you want a function to to prove it onto, you have to show that the range is subset of B. Range is equal to B. That's what we have to show. But now, in order to show these two, um, these two things, okay? So, like this equality, what you have to show two things. So, in order to show that range of the function f is equal to the B, you have to show what we have to show, because these are two sets. I have to show the equality of them. So I have to show that the range of function f is a subset of B, okay? And B is a subset of the range of f. That's what we have to show actually. That range must be a subset of B and B is subset of, range f. Now my claim is that this that range is a subset of the codomain is always true. Is always true. Okay? If f is a function, it must be always true. Can you justify that why this is always true? Why this is always true? Why range is always a subset of the codomain?
Because all
Because
elements,
they are equal.
Because
all
they're equal.
elements of A must be matched to B.
Because, yes, if it's onto.
No. Okay? Like
सर जो पहले वाली डेफिनेशन है ना हमारी
जी,
सेट की, जो सारे के सारे एलिमेंट ए के हैं वो बी में होने चाहिए, किसी न
नहीं.
किसी नंबर से मैच करने चाहिए, नहीं है?
Not all elements of A
तो
should be
यही
in
तो
B. That's not correct way to say, but I can see where you are going at. Okay?
मतलब रेंज बी के बराबर होनी चाहिए,
नहीं
तो
नहीं, बराबर तो
रेंज
है.
में सबसेट होगी ना
नहीं नहीं,
B।
that's what I have
हाँ,
to that's what I have to basically show in order to show that a function is an odd. ठीक है? If I have to show
अच्छा,
that range of f is equal to b, then I have to prove these two conditions. My point is there is no need to prove this condition. Okay, when you want to prove the equality, just prove this. Okay, but I want to listen from you. I want to dig this out from you, that why this is always true. Okay, why this is always true, Jay?
Sir, because in function range of f always subset of b. Jo.
Why?
If range of f does not subset of b, then this is not function.
Exactly. But okay, like okay, that's intuitive way to say it. But if I have to show that range of f is a subset of b, I know a criteria. I know how to prove one thing is a subset of another thing. Okay, I
Sir,
know.
according to equality, A is, if for suppose A बराबर B के, तो A is subset of B, B is subset of A. In ant function, codomain is equal to the range.
नहीं
We
नहीं
can say
नहीं, मैं ये
that
कह रहा हूँ मेरे भैया, मैं ये कह रहा हूँ कि मुझे ये साबित करना है. मुझे नहीं पता कि ये है या नहीं. So I can't say that my given function is onto at the moment. I want to know that if I give you a function, how you are going to know that this function is onto. ये समझ लें बात. मैं ये नहीं कह रहा कि function onto है. अगर onto है तो फिर तो उसे prove करने की जरूरत ही नहीं है. अगर मैं आपको
function
जी
सर हम फंक्शन की डेफिनेशन में पढ़ के आए ना, और वहां साबित करके आए ना, रेंज ऑफ एफ सबसेट ऑलवेज बी जे.
Have we proved it previously?
लेकिन डेफिनेशन में तो पढ़ा है ना.
Definition में किधर पढ़ा है? I want to see it from definition actually. I know one thing actually. If I have to show
Yes, sir.
that range is a subset of B, I have to pick an element from here and I have to show that this element must belong here. ठीक है ना भाई? So I just have to show this actually. So why an element, you know, like why the range of f should be subset? It's like a very trivial fact. It's you feel like, you know, range is the hoti subset hai, you know, codomain ka. So what's the point actually? But I want to realize that I want to make you realize that it is also important to, you know, it is really important basically to, you know, verify even the trivial things for the some time actually. You should know the reasoning actually. Okay? The answer is coming from that since f is a function, okay, so for okay, so let's do it properly. Okay, let's do it properly. It really follows from the definition of the function, but I want to see it explicitly that how it follows from the definition of function. So if I have to show that range of f is a subset of B, okay. By the way, you have to keep one thing in view. Don't worry about all these things that we are saying now. I'll just mention that one-liner criteria soon, okay, based on this description, okay. But I want to make you realize that where this criteria is coming from, because quite often people have just memorized, you know, that okay, that's the way to prove the onto function, but they never see that why this way of proving an onto function is really working actually. Okay, anyway, so I want to show that range of f is a subset of B. So let me take, say, for example, an element from range. What? Let me take an element from range of f. Right? Now, what kind of elements are in range of f? The range contains, so if B is an element in range of f, then B must be of this form, because in range, all elements are of this form actually, right? So if this is your domain, okay, all elements are of this form. So if I'm saying that, okay, B belongs to this range, then I'm going to say that, okay, B can be this, or B can be this, or B can be this. There is no other option actually. Okay. So if I'm saying that, you know, B belongs to the range of F, okay, then B is equal to f of A. For some, I don't know which A, but for some A in A. Okay. Now, since f is a function, f is a function. So the first condition, so one of definition of function implies that for every A, f of A must belong to B. Isn't that the case? Yeah, hai na bhai? Do you agree with me? That for every A from the domain, its image must belong to the B. Hai bhai? Anyone? You remember when we said that how to prove a function well defined? This was really the first condition actually, that the function is well defined if for every A, the output of A must be in what do you call codomain. Now, since f is a function, so this must be true. And if it is true, then this A is from A and B is equal to f of A and f of A belongs to B. So I'm going to say that B belongs to B actually. So what did you do? So you picked an element from range and you proved that this belongs to, what do you call, B. But the crucial thing is coming out of the definition of the function actually. That why this B, which is in range, must also belong to codomain. This follows from the definition of the function, and hence, you know, and hence the range is always a subset of B if f is a function actually. So for a given function, there is no need to verify this condition because this is true always. So you just have to verify this condition. All right. You have to just verify that condition. In other words, if you want to prove that range of f is equal to B, just verify that B, the codomain, is a subset of range, because range is always a subset of codomain actually. It follows from definition. So you just have to show that B is a subset of codomain. Now, in order to show that B is a subset of codomain, how can I show it? Okay. How can I show it actually? B is a subset of range of F. This is what I would like to show. So how can I show it? I need to pick an element from B. Keep in view, this is not always true for functions. If a function is onto, then it would be true actually, right? While this conclusion is always true for all functions, this conclusion. So if f is a function, then range is a subset of codomain. This is always true, okay? And the argument is here actually, like this argument. But like this second part, that B is a subset of range of f, this is not necessarily always true. This would be true for only onto functions actually. So that you can have the equality of the range, equality of domain and codomain and range actually. All right. So let's pick a B from B. And we want to show, so the question is, so what should be done? What should be done so that I can conclude that B belongs to range of F? So any suggestion? What should be done? What should be f of f, the B that you have picked from B, this also belongs to the range actually. क्या ऐसा करें जी? Okay, the B that I have picked from codomain, it also belongs to range. So the answer is simple. You know, that if you want to prove that something is in range, and in a range, the all elements are of this form. They are output of something. They're output of something. So if I want to show that B belongs to f of A, B belongs to range of A, then B must be equal to f of A for some A in A actually. So what is the net conclusion? The net conclusion is, if you want to prove that B is a subset of the range of F, you have to find an A for which B is equal to f of A. In other words, for which B is the pre-image, B is the image. In other words, in order to prove a function onto, you have to pick an arbitrary element from codomain. Okay, pick an arbitrary element from codomain like 20 and show that there is a pre-image of it. Okay, so I picked an arbitrary element from B and I showed, if I can show, okay, that there is some A in A for which B is equal to f of A, then your B would belong to also range of F, because all elements of such form belong to the range of F. So hence any B in B is going to be in range of F, and hence B is going to be the subset of range of F. But the range of F is always a subset of, what do you call, subset of B. The range of F is always a subset of B. So therefore, the range is equal to B. So if you want to prove that range is a subset of B, prove that B is a subset of range of F. And in order to prove that B is a subset of F, pick an element from codomain and try to find its preimage actually. Try to find an A on which if you apply F, you're gonna get B. Okay, so that's really is the criteria for. So let me put it precisely. Let me put it in a precise manner actually. So here's a precise manner. One-liner criteria for onto-ness of a function. Okay, so a function, let me write it, a function f from A to B is onto if for every B in B there is A in A such that B is equal to f of A. If for a function you can prove this, your function is onto. So in order to prove a function onto, pick an arbitrary element from codomain, and for this arbitrary element, try to find an element from domain such that B equal to f of A. If you can prove that, your function is onto. Okay, so quite often I have seen actually that people have memorized this definition that okay, like that's the way to prove onto, but they don't realize that why they are doing it. How by proving this you can conclude actually, okay, that your function is onto. It is because that if you are able to prove this, if you have proved this, okay, this statement, then what actually you have shown is that the B is a subset of range of F. That's what this statement is saying actually. But range is always a subset of B, the codomain. So therefore you have this equality. Okay. Therefore you have this equality. Okay. So if you can prove this, that for every B there is an A such that B equal to f of A, this is enough to prove that a function is onto. But I want to make you realize or make you comfortable with this fact that why this is enough. This is enough because if you are able to prove this, that for every B there is an A such that B equal to f of A, what you have just proved is that B is a subset of range of F. And hence B must be equal to range of F, and that's what is our definition of the codomain actually. And that's what is our definition of what do you call onto function actually. समझ आ रही है बात? Anyone? Are we happy with this conclusion?
Yes, sir.
ये समझ में नहीं आया दूसरा
जी हेलो
सेकंड क्रिएटिव अगर ये थोड़ा समझा दें
क्या
रिपीट
मतलब
कर दें
देखें let me show it, let me say it again, ठीक है onto-ness की, so there is only one definition of onto-ness, that range should be equal to codomain.
और
If you want
before
to prove that range of function is equal to codomain, you have to show that the range is subset of B, and you have to show that B is subset of range of F. Okay?
Yes, sir.
This is always true. This is always true for functions. So that means you don't have to show this. So you have to only verify that every B, the B is a subset of range of F. And make yourself now comfortable that if I can prove this, that every B is equal to some F of A, and F of A is an element in range, this really shows that this criteria really verifies that B is a subset of range of F, and hence range of F is equal to B. Why? Because if B, think about it, if every B can be written in such form and all such elements belong to range, does this belong to range? है भाई, ये f of a रेंज से बिलोंग करेगा?
Yes, sir.
करेगा ना? तो आपने क्या किया? You have proved that every B, if this belongs to a range of f, that means that B belongs to range of f. And what did you just proved or just shown? That every B from B belongs to the range of f. So this means that B must be a subset of range of f. And if B is subset of range of f is always subset of B. This is going to prove that range of f is equal to B actually. Okay? So whenever you want to prove a function onto, prove this. And if you can prove this, this is enough to show that the range of the function is equal to the codomain actually. बस ये करना है आपने. ठीक है? जी जी.
सर आपने कहा कि ये बी सबसेट रेंज ऑफ एफ ये
जी.
नॉट ऑलवेज ट्रू है,
जी
ऑलवेज ट्रू नहीं होता.
जी जी.
क्यों सर?
इसलिए नहीं होता क्योंकि जरूरी तो नहीं है कि हर एलिमेंट बी का किसी न किसी का इमेज हो. फॉर एग्जांपल वी सॉ दिस एग्जांपल why physics and math and English and 10 20 30, for example, if I put a 40 and I say that math is 30, English is 40, so what is range? Range is 10 20 30. What is codomain? Codomain is 10 20 30 40. In other words, there is a 40. इसकी negation करें. इसकी negation क्या होगी इस statement की? That for every B there is an A such that B equal to f of A. Then इसकी negation क्या होगी? Anyone?
There exists a B.
There exists a B in codomain
Yes, sir.
for which there is no.
If sir,
अब ये कह सकते हैं for which there is no A in A such that f of A is equal to B. यही होगी ना negation में.
yes sir.
ठीक है. So for 40, is there an element in domain for which I can say that 40 is equal to f of something? No, there is no. So hence this is not onto. Not onto. ठीक है. So if some function is not onto, that means there are elements in codomain which are not images of anything from domain actually. And hence range is not equal to the entire domain. Okay? So keep only this condition in head that if you want to prove a function onto,
yes sir.
okay? If you want to prove a function onto, okay? What would be the strategy to prove a function onto? Pick arbitrary B from B and try to find an A from A such that B is the image of f of A. So if you can prove this, your function is onto. समझ आ रही है बात? But I don't want to just memorize this condition actually, that okay, this is enough to prove onto, but I want to make you realize that why this is enough actually. Because once you prove it, you have proved that B is a subset of range of F. The codomain is a subset of range of F, and hence the domain and range, codomain and range are equal actually. So therefore the function is onto. Okay, so let's do some examples. समझ आ रही है बात?
Yes, sir. Sir, if we are asked in exam, we should prove only one thing here, like
You just prove this. For example, if you have been said to prove a function is onto, just do this. That's it. You don't
okay,
have to
thank you.
explain all this. That, okay? But as I am saying, you have to kind of appreciate basically this, that why this is enough actually to prove the function is onto. Okay? ये क्यों हो रहा है? Okay, so let's do some examples. So let's now prove that a function from say R to R defined by say y equal to f of x, but f of x is really equal to 2x plus 3 is onto. Okay, is onto. चलो ये ना भी लिखें, y equal to f of x doesn't matter. ठीक है भाई, is onto. So how can I prove that this function is onto? For this, I have to pick an arbitrary element from, what do you say, codomain, and try to find an input for that point from domain actually. That's it. Pick an output from codomain, pick an element from codomain and try to find an input for that. If you are able to do it, your function is onto. So if I, for example, pick an arbitrary y from R, so y can be anything. I have no idea what is this y is. Okay? Like I'm picking this from codomain. Okay? And I want to find an x. We want to find an x from domain such that y equal to f of x. The question is, can I find this x? The answer is why not? So you have this 2x plus 3. So if I can, so try to write the x in the terms of the y. So what would be x in the terms of the y? So it's going to be y minus 3 divided by 2 is going to be equal to x. Okay? Y equal to y minus 3 upon 2 is going to be x. So bring 3 on the other side and divide by 2, so you're going to get x. And my claim is this is the x on which if you apply your function f, you're going to get y. So let's apply it. So f of x, which is equal to f of y minus 3 upon 2. And if I apply f onto this y minus 3 upon 2, what are you going to get? 2 times of y minus 3 upon 2 and plus 2. Okay? Plus 3 by definition. Okay? Because what is the definition? If you put an x, the output would be multiplied with 2 plus 3. So what is the input now? Y minus 3 upon 2. So the output would be that y minus 3 upon 2 multiplied by 2 plus 3. So the 2 get cancelled. And if you simplify, negative 3 and positive 3 will get cancelled and you get a y. समझ आ रही है बात? So for an arbitrary y, we found an x such that when we operate rf onto that x, we get y. Hence, my function is onto. Hence, function f is onto. ठीक है मेरे भाई? So that's what essentially you have to do in order to prove a function to be onto actually. समझ आ रही है बात? So give me
Yes, sir.
another function, for example, say I have a function from say R to R, and it is defined as f of x equal to x square. Is this function onto? If this function is onto, then for every real number from here, we must be able to get an input such that when we apply our f onto that input, we get our required real number. So can I say that this is onto? So can I say that if I'm taking y to be a real number, I can find an x such that y equal to f of x. Okay, in other words, x square. Can I find an x? In other words, I'm saying that is every real number is a square of something. The answer is no. Why? Because think about it. Let's pick -1 from R. So I'm picking -1 from R. Can we find an x from R such that f of x is equal to -1? In other words, such that x square is equal to -1. So can you find a real number whose square is -1?
No, sir.
So this function is not onto. Hence, f is not onto. If you want to prove onto, prove it generally that for every y there is an x. If you want to disprove onto, just pick one such element from codomain for which there is no, what do you call, there is no input actually. There is no x from the domain such that f of x equal to that number actually. J.
सर कोई भी फंक्शन अगर कोई जनरल वैल्यू को हमने जनरल वैल्यू मतलब एक्स वाई वो भी तो रियल नंबर्स है ना, तो अगर एक जनरल वैल्यू के लिए स्पेसिफाई करता है तो वो हर वैल्यू के लिए स्पेसिफाई कर, ये लाजमी नहीं है?
नहीं, जरूरी नहीं है। ठीक है, जैसे फॉर एग्जांपल फ्रॉम हियर यू गॉट y इक्वल टू x स्क्वायर, so I can deduce that okay, x must be square root of y actually. But the question is, can I calculate the square root of all y's? Is x equal to square root of y is always a real number? The answer is no.
Yes, sir.
The answer is no. If y is negative, x is not a real number actually.
ये सर फिर हम ये नहीं कह सकते ना कि y belongs to real numbers.
नहीं, y देखना, y तो हमने रियल नंबर लिया है पक्का. So we have picked a y that is a real number. Now the real numbers can be positive, can be negative, can be, zero actually. Okay. Yes. Now if x is equal to square root of y, I am saying that you just have to verify that, okay, is this formula for x, which is in the terms of y, is always a real number? So this is not always a real number. For example, here, the formula for x in the terms of y is always a real number. So if y is a real number, y minus 3 upon 2 is a real number. But here, x equal to square root of y is not a real number actually. Always. If y is negative, it's not a real number actually. So if there are some y's for which x is not real numbers, your function is not onto. Okay? Your function is not onto. That's what essentially you have to do. Or just show one point actually, which cannot be written as the what do you call, output of something else. Okay?
Okay, sir.
Here is an interesting example. So here is an interesting example. So this is really a little theorem actually. So it says that, okay, let's take A to be a set that is X belongs to R such that X is not -1. Okay, so here is, so maybe you can call it a theorem or example or whatever. You know, this book calls everything a theorem, which is interesting. So X is a real number such that X is not -1. So in other words, this is R set of real number minus -1 actually. So everything is included in this set except -1. And F is a function from R to, no, from A to R. Okay. F is a function from A to R defined by that f of X is equal to 2x over X plus 1. 2x over X plus 1. And I want to see that, is this function onto? Is this onto? Then then you can do rough work. Let's do some rough work. Okay. So what we have to do, I have to pick Y from R. So can I find an X from A such that Y equal to f of X? So if I can find for every Y, I can find an X, Y equal to f of X, you know, my function is onto. But if Y is f of X, what it would be? So it's going to be 2x over X plus 1. And then try to write the, you know, X in the terms of Y. So can I write X in the terms of Y? So Y times X plus 1 equal to, say, 2x. So xy plus y equal to 2x. I can say that I have y equal to 2x minus xy. So I have to isolate x actually. So y over or y equal to 2 minus y times, what do you say, x? So hence x is y over 2 minus y. समझ आ रही है बात? Andy?
Yes, sir.
Okay. Now here's the thing, that the key thing is this, that okay, the formula that you have found for x for every y, is this formula is a real number actually. So you have to just check it. So can I say that for every y this formula is a real number?
No, sir. For
Y equal to 2. Y equal to 2 is the trouble actually. So this means that there is a y for which there is no x. And let's try to, for example, you know, do it actually. Okay, that take, so if I have to root, so from my rough work, I can say that take y from, so take 2 from a real number. Question is, can we find x, can we find x such that f of x is equal to 2? The answer is, you know, let's try to find it. In other words, 2x over x plus 1 is equal to 2. So if I divide both sides by 2, you're gonna get, or maybe you can have 2x times 2x times x plus 1. So, you know, you get 2x equal to 2x plus 2. And is there an x actually for which this is true? The answer is there is no such x actually, right?
Yes, sir.
समझ आ रही ना? There is no such x for which this is true. Because if there is such x, तो 0, 2 के बराबर आ जाएगा. That would be something strange actually. Okay, so there is no such x for which this is true, and hence there is no such x for which this is true, and therefore I can say that there is no an x from a for which f of x is equal to 2, hence f is not onto. F is not onto. Okay. So the trick is this actually, always equate your y to f of x. Okay. Try to find x in the terms of y, and then see that the formula that you have found of for x in the terms of y, does this guy make sense for all y's actually? So if it makes sense for all y's, probably your function is onto. But if there is a y for which x is nonsense, probably your function is not onto. And then take that particular y for which your formula for x is becoming nonsense and try to find an x. You will never find an x actually. So that's the strategy to prove that some function is onto or not actually.
सर,
Okay. जी.
सर इसमें सर
जी.
सर इसमें जो फंक्शन में a लिखा हुआ है, फर्स्ट उस क्वेश्चन में a जो अब रियल से रियल तक जाए तो हम ये बता सकते कोई भी x की वैल्यू रियल लेके. अब a लिखा तो a कौन सा सेट हो गया?
नहीं, a तो ये है ना सेट, ये सेट है.
a को सही है सर, a को डिफाइन किया गया सही है.
नहीं डिफाइन किया गया. So it's a set of all real numbers except -1. ठीक है, ठीक है जी. और वो -1 भी क्यों दिया है? इस वजह से दिया है ताकि फार्मूला शुड देखें. So has a very good point actually. You can ask why you have this x equal to -1. इसलिए because function तो बने ना. Because if you include x equal to -1 here, the function would not be a function actually. Because at x equal to -1, this is going to explode. Okay. But this function is not onto. Okay. So that's how you prove the onto. There are plenty of functions actually. Such functions. Okay. Challenging. So are we happy with this? So let's write a summary. In order to prove f from a to b onto, you have to prove for all b in b, there is a in a such that b equal to f of a. ठीक है. मगर इससे onto कैसे साबित होगा? इससे onto इसलिए साबित हो जाएगा because this is going to imply that b is the subset of range of f. ठीक है. Or range is always a subset of b. So therefore b is equal to range of f. And hence this is what is the definition of function of onto. This is not the definition of the function of onto. This is a sufficient condition to prove that a given function is onto. याद रखनी है बात. ठीक है. Some people just treat this as the definition. There's nothing wrong in it, but the best is that you should treat this statement as a criteria to prove that your function is, onto, because this is going to prove that b is subset of range and hence b would be equal to range actually. Okay. So these things are very important to realize that why the things are the way they are. Okay. Let's now move and talk about the functions which are onto, which are one and onto both actually. So let's talk about inverse function actually. Inverse function. So here's an interesting question. If f from question, if f from A to B is a function, okay, then the f inverse, okay, but what I need to know that I need to explain first that what do I mean by f inverse actually. So let me give you an example first and then write this question actually, because then this is going to make sense more. So let's have A in which you have physics and math and English and say biology, and you have um, um, what, say 10 and 20 and 30. Okay, this is your B, and let's do this. That 10 is physics is 10, math is also 10, English is 20, and physics is 30. Okay. And this assignment is F actually. What are some of the properties of this function? First of all, this is a function. You agree that this is a function?
Yes, sir.
Yes.
Okay. And this is also onto.
Yes, sir.
All right. Okay. So now if I just, imagine that if, now if I put B here and A here and keep the assignments the same. So in other words, I put 10, 20, and 30, and I put P, M, E, and B actually. And I keep the same assignments. So here the P and M are related with 10. So let's do the 10 is related with P and M. Okay. The 20 is related with E and 30 is related with B actually. I'm gonna call this as the inverse of the function. The question is this inverse that I have defined, which you can treat as the reverse actually, is this a function?
Function नहीं है sir.
Function nahi hai. That's not a function. Okay, so the inverse means make all images pre-images and pre-images images actually. Okay, so just flip the picture. Okay, just flip the picture. Acha ji. So if a function is function n onto, it's not necessarily inverse is not function actually always. So for example, let's do another example. Let's do this. A, B is this and B is this, and say I have a P and M and B here, and I have say 10, 20, 30 here, and I say that, okay, the physics is 20, 10, and the mathematics is 30, okay, and okay, so let's say remove E and B. Let's remove E and B. Now, is this a function?
Yes, sir.
Yes.
It's a
Yes,
function.
sir.
What else you can say about this function?
This is
One
not
to
onto.
one.
This is not onto,
One-to-one function.
Yeah.
but it is also 1-1, right?
Okay.
Let's invert it. So like this function was, function n onto, but the inverse is not function. How about now if I do this, that B, and I write A, and I write 10, 20, 30, and I just revert the situation actually, and I say that, okay, the 10 is physics, and say the 30 is mathematics. So is this a function?
Yes, sir.
Is it?
No, sir.
क्यों?
No, sir.
क्यों
No,
नहीं है?
sir.
No, sir.
क्यों नहीं
Yes,
है?
sir.
किसने नहीं बोला?
Because
सर डोमेन कंप्लीट फिल नहीं है ना सर?
कंप्लीट फिल नहीं है ना 20 में 20
इस तरह ना याद रखें डोमेन कंप्लीट फिल नहीं है. Tell me the definition.
सर
Definition
20 के लिए
says
इमेज नहीं है.
exactly. ठीक है?
Yes, not sir.
So the for 20 there is no image actually. So therefore this is not a function. So if your function is 1 1, its inverse is not, not a function. If your function is onto the inverse is not a function. Okay. So can I say that does every function has inverse? I want to
No,
just
sir.
know.
No, sir.
No sir, not necessary.
Not necessary. So then how about if I do this PME and I say that 10, 20 and 30? And so this is f actually. Okay, so this f is a function plus it's also 1 1 plus it's also onto, right? So it's inverse
Yes,
of
sir.
function 10, 20 and 30 and P, M and E. Are you getting the point? So
yes sir.
so the 10 is related with M, and say P is 30 is related with P, and 20 is related with both E. Okay, 20 is related with E. So is this a function?
Yes sir.
So interestingly, this is indeed a function actually. Okay, so from this observation, you can take any other such situation in which you have function and 1 1 and onto. Okay, you will always see that your f is the inverse of f is a function actually. The inverse of f is a function. Okay, and you can see that for function and its inverse, there is something interesting actually. And what is that interesting? So from function I see that f of p is what, 30, right? And for its inverse, f inverse of 30 is what?
P, sir.
It's p. So f of m is 10. So you can see it from here. But how about f inverse of 10?
M.
It's going to be m, and so on and so forth. So you can see that if a function has inverse, and I say that y is equal to f of x, then what would be the formula for the inverse of the function? F inverse of x equal to 1. Okay. So for y, try to find an x, okay, for which y equal to f of x. If you are able to do it, then your f inverse of x would be equal to, what do you call, y. Okay. So let me write a theorem actually and prove it in general. So what you have observed, maybe this is true for this function, not for other functions, but I'm going to prove that this is true in general, that if your function is 1 1 and onto, your function is indeed has an inverse actually. And interestingly, you can also see that the inverse is also 1 1 and onto in it.
Yes, sir.
This is also 1 1 and onto. Okay. All right. So let's prove a theorem, okay, which is a bit interesting theorem. So here's the theorem that says that suppose f from A to B is 1 1 and on 2, okay, then there is a function f inverse that satisfies, okay, this, that f inverse of B is equal to A if and only if f of A is equal to B. Okay. In fact, this f inverse that you have, okay, I must say that f inverse must be a function from B to A. In fact, f inverse from B to A is also 1 1 and on 2. Okay, so f inverse is also 1 1 and on 2. Okay, now so what does the statement say? Statement says that imagine you have a function, and for this function you know that it's 1 1 and on 2. Then this allow you to define another function, okay, which is the inverse function from B to A. And what would be the definition of the inverse function? That whenever f inverse is operated onto B, which is an element of A, which is an element of B, this would be equal to A. And which A? For which f of A is equal to B. So if f of A is equal to B, then in other words, if B is the image of A under F, then A is the image of B under F inverse actually. Okay? That's what it is. And if A is the image of B under F inverse, then B is the image of A under F actually. ठीक है, ये एक ही बात को कहने के दो तरीके से. This is just, you know, so it's like it's the two ways to say the same thing actually. Okay, so in fact f inverse of B is also and 1 1 and on to function actually. Okay, so this is what that I would like to prove. So let's prove. So first what we will prove. So the first thing is that okay, if you are claiming that this f inverse is a function, is it a function? So how do I know that if f from A to B is 1 1 and on 2, then f inverse is the function actually. So let's prove that f inverse is well defined. F inverse is well defined. And what we have to prove to prove that f is well defined, I have to prove,
Yes, sir.
for every
A and B belongs to
B in B, f inverse of B belongs to A. That's what you have to prove actually. Okay? For every element in domain, if you operate your function onto the element of domain, it should go into the codomain. Okay? So f inverse is the function from B to A. So for every element in domain, You should have an element for which the for which there is an element for f inverse of b is must be an element in A actually. Okay, this is what that you have to prove. Okay, this is what that we have to prove. So how can I prove it? So what is given? So given is that exactly given is that b is in B. Okay, but we know, so we know that f is onto. Okay, so there is an A in A such that B is equal to f of A. Okay, because B a onto function, it is given to me that f is onto. F is 1 and onto, so it's onto. So if it is onto, then for every element here, I can find an element here such that B equal to f of A. But it is given to us that whenever B is equal to f of A, f inverse of B is equal to A. So this means, hence, f inverse of B is equal to what? A. Now, from where A belongs to A. So this guy belongs to A. So if this belongs to A, what does it mean? F inverse of B belongs to A. So what we showed, we picked an element from B and we proved that its inverse image belongs to A. Okay. So F inverse of B is equal to A, but since A is in A, so F inverse of B must also be in A actually. So the first condition of F inverse being well defined is true. ठीक है मेरे भाई, समझ आ रही है बात?
So last step,
देखो ना, last step ये है कि भाई ये you have to keep in view that you have been given that whenever f of A is equal to B, you can say that f inverse of B is A. And whenever f inverse of B is A, f of A equal to B. Now here, if you have been given that, B belongs to B and f is onto, so therefore there must be an A in A such that B equal to f of A. So if B equal to f of A, then from our given definition of f inverse of B must be A. So I can deduce that f inverse of B must be A. So if f inverse of B is in A and A belongs to A, this means
f inverse of B belongs to A.
Exactly. So what we showed, I picked an element from domain and I proved that its inverse image also belongs to codomain actually. Okay. So the first condition of f inverse being function is true. So what we need to do the second condition. So in order to prove the second condition, I need to say that let you have two elements, say B and B prime from what do you call? And by the way, in the first part, you see that ontoness played a crucial role. Okay, ontoness played a crucial role. Now let's think about the second condition. So let's say that B and B prime are from B such that B is equal to B prime. We need to prove, what we need to prove? That f inverse of B is equal to f inverse of B prime. In other words, if inputs are equal, then their outputs are also equal. That's what I have to prove actually. यही होती है ना भाई second condition इसकी. That's what is really the second condition of a function being well defined. That if the two inputs are equal, then their outputs are equal. Now, what are the inputs? From where I must take the inputs from for the function f inverse? So I have to take the inputs from B actually. So I pick two B's such that those are equal, and I need to prove that their inverse images are also equal actually. Okay. But how can I prove it? The same trick would work. Now, as B and B prime are from B and F is on 2, so there must be A and A prime, right? Such that B equal to F of A and B prime equal to F of A prime actually. ठीक हो गया? Right? And what is given to me, the given is that B is equal to B prime. That is, by the way, what else will follow from that B is equal to F of A? That is, this means that F inverse of A is B. No, F inverse of B is A actually, right? And what also follows from here that F inverse of B prime is A prime. एक ही बात है ना, एक ही बात को कहने की. So that's just, you know, by definition that if F of A is B, then F inverse of B is A. So since B is F of A, so I can say F inverse of B is A. And since B prime is F of A prime, so F inverse of B prime is A prime. Okay? So this is the conclusion that we got from previously. Now it is given to me that B equal to B prime. That is B, which is F of A equal to F of A prime. Now, do I know something about F actually in such situation? I know that F is 1, 1. And what is the definition for 1, 1? That if outputs are equal, then inputs must be equal. Right? यही definition होती है, 1, 1 होने की. ठीक है?
Yes, sir.
If the outputs are equal, then inputs must be equal. The sufficient condition. So
Yes,
if
sir.
the inputs are equal, I can say A is what? F inverse of B. And A prime is what? F inverse of B prime. So from where we started? We started that B is B prime. And what we proved? We proved F inverse of B is equal to F inverse of B prime. Hence, so what does follows? That hence, your F inverse from B to A is indeed a function. It's indeed a function actually. समझ आ रही है बात? ठीक है? So you see that how one-oneness and onto-ness are helping you to prove that your F inverse that you have defined in this manner is really, what do you call, a function actually. But we have to prove additionally also that F inverse is 1, 1 and F inverse is also onto actually. ठीक है जी? So this is what I have to also prove. So let's prove that F inverse is 1, 1. F inverse is 1, 1. So what I need to show to prove F inverse is 1, 1. I need to pick two elements from domain, like B and B prime are two elements from domain, such that F inverse of B equal to F inverse of B prime. And we need to show, क्या show करना चाहिए? In order to prove F inverse is 1, 1.
That B is equal to B prime.
Exactly. We need to prove that the inputs are equal actually. B is equal to B prime. So that will prove that F is 1, 1. So how can I prove it? Again, the same trick would work actually. Okay? So as B and B prime belongs to B, as B and B prime belong to B, and maybe I must write it at some more convenient place. So let's prove this claim. So I need to show that. So I have assumed this, and I have to prove that B is equal to B. The outputs are equal, so we have to show that input must be equal. So it is given to me that B and B prime are from B. So so as F is onto, so there must be A and A prime from A such that B equal to F of A and B equal to F of A and B prime equal to F of A prime, right? ऐसे ही है ना भाई?
Yes, sir.
That is, from this I can conclude that A is same as F inverse of B and A prime is same as F inverse of B prime. ठीक है? Now we are in position to prove our claim. Now it is given to me that F inverse of B is equal to F inverse of B prime. So if F inverse of B is equal to F inverse of B prime and F inverse of B prime, if F inverse of B is A and F inverse of B prime is A prime, so this means that A must be equal to A prime. Since this is equal, then these two guys must also be equal. And if these two guys are equal, then F of A must be equal to F of A prime. Can someone tell me why? Why if A is equal to A prime, then F of A equal to F of A prime? Since F is a function.
Yes, sir. And 1-to-1 function.
नहीं 1-to-1 की जरूरत नहीं है यहाँ पर.
Sir, input same है तो.
नहीं. So this is the second part of the definition of function being well defined actually. ठीक है? You have to keep in view. Output के 1-1 के लिए you have the opposite actually. ठीक है? समझ आ रही है बात?
सही है sir.
Since F is a function, so F of A must be equal to F prime. But what is F of A? That's B. What is F of A prime? That's B prime. So what we did, we proved actually that if F inverse of B is equal to F inverse of B prime, then B must be equal to B prime. समझ आ रही है बात? So hence F inverse is 1-1 actually. ठीक है? Try to prove for yourself that F inverse is onto. वो आपने खुद कर दे. ठीक है? Try to prove it for yourself that why F inverse is onto. ठीक है? So this theorem give you a beautiful description that for if your function is 1-1 and onto, your function has an inverse. And this recipe tells you that how to find that inverse actually. So this recipe is telling you that how can I find F inverse of some B actually? Okay. So the answer that it gives is that try to find an A for which f of A is equal to B. If we can find an A for which f of A equal to B, then by this theorem f inverse of B would be equal to that A actually. Okay? So let's try to find some inverses of the functions actually. ठीक है जी, समझ आ रही है बात थोड़ी थोड़ी सी?
Yes, sir.
चले, और any all other people, or they are they with us as well, right?
Yes, sir.
चले जी, चले ठीक. Now how to find the inverse function? So imagine I have been given a function. So I hope you have learned this in calculus. Have you learned to find the inverse function in calculus?
Yes, sir.
Okay, so
Yes, sir.
you know how to find the inverse function. So now you can see that why that strategy that you have learned in your calculus works actually for finding the inverse function. So how do you find the inverse function? You say that, okay, let's take y and equate it to x, okay? And then try to write x as some function of y, right? This function is going to be the inverse of f. ऐसे ही पढ़ते हैं?
Sir.
Yes, sir.
So if you have been given a function, but now you can see that why this strategy works. So imagine that I have a function f of x equal to say 2x plus 3, and this is a function from R to R, okay? But in order to find the inverse function, first you have to verify that this function is 1, 1 and onto. ऐसा ही है ना भाई? हर function, not every function has inverse. So if you want to prove that a function has an inverse, first prove it that it's 1, 1 and onto. So we have proved it already. I'm not going to repeat it actually. Okay? So this f is 1, 1 and onto. Now how to find inverse? So where is it f inverse? F inverse is going to be an element from R to R. So the question is, how can I find that f inverse operated onto some b is equal to what actually? Is equal to. So what you have to do in order to find that f inverse of b is equal to what? Let's find f of what equal to b. Okay? So if you want to find f inverse of b equal to what, try to find f of what equal to b. Because if I can find f of what equal to b, then by previous theorem, f inverse of b equal to is going to be equal to that what actually. समझ आ रही है बात?
Yes, sir.
ठीक है ना?
Yes, sir.
So if you want to find f inverse of b equal to what, try to find f of what is equal to b. So if you can find that what, so just substitute that what here, so that would be f inverse of b actually. Okay? So let's say that I don't know what is that what. Let's call that what a. Okay? So f of a equal to what? B. Right? And I don't know the a. The a is unknown to me. So how can I find my a now? How can I find my a now? So the f of a is really the 2a plus 3 equal to b. So the a must be b minus 3 upon 2. So we found the a. Okay. Hence, I'm gonna say that f of a, which is f of b minus 3 upon 2, which if we compute it, it's gonna be what? 2 times of b minus 3 upon 2 plus 3, right? And if you simplify it, you get b actually, right? So f of this is equal to b. Hence, or thus, you're gonna say that f inverse of b is equal to what? This thing that you have found. In other words, b minus 3 upon 2. Okay? If you want to write it in the terms of x, doesn't matter. The f inverse of x is equal to x minus 3 upon 2. So that's really the inverse function of the given function. Okay? So this is a trick actually to find the inverse of function. Okay? But this trick, it really works in calculus actually. It really works in calculus. ठीक है जी.
सर तो सर तमाम 1-to-1 फंक्शन का इनवर्स एग्जिस्ट नहीं करता, सारे 1-to-1 का सर.
हर 1-to-1 का नहीं करता. Yes. So not every 1-to-1 function has inverse. Not every onto function has inverse. Both 1-1 and onto function has inverses actually. ये याद रखनी है. ठीक है? So if a function is both 1-1 and onto, then you have the inverse of those functions actually. ठीक है जी.
तो हमने तो कैलकुलस में पढ़ा था कि जब वर्टिकल लाइन टेस्ट में कोई भी फंक्शन अगर सही है तो उसको आप वो निकाल सकते हैं.
तो वो तभी हो सकता है ना कि जब वो फंक्शन 1-1 और onto. वर्टिकल लाइन टेस्ट जो है, the vertical line test is for a function. Okay, नहीं. So this is a good point actually. आपने फिर ये गलत समझा होगा. So here's the thing. So take a parabola. Okay. So this is x-axis and this is what you call y-axis. Now vertical line test is a test to verify that a given function is a function or not. Okay. So in other words, for every x, there is a unique y output. So there is always a unique output actually, no matter where you go. Okay. No matter where you go. But what would be the inverse function? The inverse function would be now that now give this name y-axis and this x-axis and try to make the same picture. Now the picture would be look like this actually. That's really is the inverse of this. Question, is this function, is this thing that you have defined is a function or not actually?
Not a function, sir.
That's not a function actually.
Yes.
That's not a function. Okay? So what should I do that so that it become a function actually? So you can do several things. For example, what if I take only this part of y equal to x square? And so like this is my x-axis and this is my x-axis. So I'm not taking this part. I'm just taking this part of y equal to x square. So what would be the inverse of it?
वो भी function होगा.
Y and x. So this is going to be a function actually, something like this. Because this is a function, why? Because for every x you have a y. And this guy is inverse function because for every y you have x actually.
और फिर horizontal line test होता था 1-to-1 को check करने.
1-to-1 के लिए horizontal line test. Or you can see that this satisfies the horizontal line test as well. While this guy does not satisfy the horizontal line test.
सर ये तो 1-to-1 भी नहीं है ना.
ये तो 1-to-1 भी नहीं है तो bijection भी नहीं होगा. ठीक है?
तो सर मैं ऐसे कह रहा हूँ कोई फंक्शन जो इस हॉरिजॉन्टल लाइन टेस्ट को पास करे लेकिन वह उसके इनवर्स एग्जिस्ट ना करे, वो कैसे हो सकता है?
हाँ, ये भी that's a good question. Horizontal line test का मतलब है so that function must be okay, so वो 1-to-1 होगा मगर onto नहीं होगा. So here's the thing. So that's a good point actually. That's a good point. So how can I construct a function that is so take this function, the same function actually. Let's not take this entire curve. Let's not take this entire curve. So here the domain is what? Entire real line, and codomain is what? The entire real line, right? I'm saying now let's take what do you say? अच्छा ये फिर अच्छा फंक्शन नहीं है ना, ये अच्छा फंक्शन ये तो ना 1 1 and 2, ठीक है? So let's take another thing actually. So let's take a function that is kind of 1 1. For example, let me take for example this. Let's take for example this actually. So is this a 1 1 and 2 function?
Yes sir, 1 1 तो है.
Sorry, 1 1 the है. So this function is 1 1. ठीक है? Or is this a function? The function is indeed a function. So what is the domain of this function? It's entire real line, and the codomain is also entire real line actually. ठीक है? Say the okay, let's define in this manner. Okay, so what would be the inverse of this actually? The inverse of this is going to be that just rotate this picture 90 degree. ठीक है? So
सर सर 90 होता है या सर 180 लेते हैं सर?
180 sorry 180 flip कर दें, ठीक है? So if this is your x-axis and this is your y-axis, ठीक है? So make this y-axis and make this x-axis actually, ठीक है? The one trouble that you're gonna have is that the function that is only function plus 1 1, okay, 1 1 is when you're gonna not onto actually. It's not onto, for example. ठीक है? It's not onto. So for example, यहाँ पर अगर मैं ले लूं, क्या ले लूं?
इसकी तो इनवर्स एग्जिस्ट करती है.
नहीं इनवर्स एग्जिस्ट नहीं कर रही. इस वजह से नहीं कर रही, मैं आपको बताता हूँ. एक मिनट, सिर्फ मैं आपको बताता हूँ कि आप एक फंक्शन ले लें जिसकी, if I say that what should be the domain of this function, if you take this function here, इस टुकड़े पर लें, ठीक है? तो this would be the domain actually of the function, ठीक है? But what if I take this entire line as the domain of the function, okay? And I say that on the rest of the points, ठीक है? इस interval पर तो इसका behavior ये है, but on the rest of the points it is 0. It is 0. ठीक है? So if you now revert this picture, how does it going to look like here actually? How does it going to look like here? So it's gonna look like okay. It's gonna, so इसको flip करना पड़ेगा. So ये जो ऊपर है part, this is going to be like this. So it's going to be something like this actually. ठीक है? ऐसे ही होगा? So
yes sir, yes sir.
It's going to be something like this. Now, why this guy is not a function actually? ठीक है? इसको मैं क्यों नहीं कह रहा हूँ? Because अगर इसकी domain हम restrict कर दे, then this is a function. Domain is not a function because this function is not defined for all values of the domain actually. it's only defined for some part of the domain. समझ आ रही है बात? So
Yes,
if you take an onto a one function, ठीक है, for example, you know, यहाँ से ज़्यादा आसानी से समझ आएगा ये P, M, E, and if I say that okay, you have this 10, 20, and 30, ठीक है, and you say that okay, your P is or maybe do this, P is 10 and M is 20, so it's a function and one and onto, but you flip it, 10, 20, and 30. 10, 20, and 30, okay, and you do the P and M, then this is not going to be function because there are going to be some inputs for which you don't have any output actually. So tabhi, whenever you deal with such functions, you say that this is a function from interval 0 to a to some r actually. Okay? You say it's a function from 0 to a. You don't call it a function from r to r. Because if you want to invert it, invert might not exist actually. Okay? So tabi, let me give you another example. You know, there's an important point basically to realize. Let me give you another example. Why the inverse of a sine function is not a function. So I know that sine function is a function actually. So it goes something like this actually. Something like this. So that's x-axis and this is y-axis. That's a
yes, sir.
Because it satisfies vertical line test, so it must be a function. But if you invert it and make it x-axis and y-axis, then and you redraw it, so it's going to be something like this. Would that be a function? The answer is no. This does not passes the vertical line test actually, because for one input there are, sorry, put y here and x here. Yes. Okay?
सही है सर.
For one y you are getting multiple x. Okay? But there are some conditions under which this is going to be function. For example, if you don't consider the entire part of it, but you consider
domain को restrict करते हैं
restrict कर दें, इतना कर दें, if I take only this piece actually 0 to pi by 2, then that's a function actually. Then that's a function. Take as if you take only this piece of what do you call sine x, not all, then that's a function actually. ऐसा ही है ना? Because this is going to satisfy the. So तभी आप जो है, you know, you for the inverse of the sine inverse function, you have the limited domain actually. You don't have, you know, the entire domain. You pick the pieces, different pieces. ठीक है? For which you get some function. ठीक है मेरे भाई? ठीक है? So see, the things that we are doing are very much related with the things that we are, you know, learning actually. ठीक है? Chale, let's do one thing. Let's do so it's 10:56. Let's do a 5 minutes break and then restart with the new things actually. ठीक है?
Okay.
Okay. Thank you. It precisely in general about all kind of functions actually, whether they are in calculus or whether they are in anywhere actually. Okay, compilation of functions. So this is important to realize. So consider, so here's a definition. Consider you have a function f, that is a function from say a to b, like a is some set and b is some set, and say g is another function from b to c. Okay, so f is a function whose domain is A and codomain is B, and g is a function whose domain is B and the codomain is C. Then I would like to define a function, new function g circle f, which I will read as g composition f, as a map from A into C. Okay, so it's going to be a map that starts from A and goes up to C actually. So in other words, f is going to throw you from A to B, and then the g is going to throw you from B to, what do you call, C. So g composition f is a map, okay, from A to C, defined as, and how do you define the composition? That g composition f operated onto some point A. Okay, so this is important to learn to read as well. So how to read it? G composition f operated onto A. Okay, so if I'm writing B equal to f of A, I can also read it as f operated onto A gives B. So I can also read it as f operated onto A gives B. All right. Right. So you can also read it as B equal to f of A. There's nothing wrong in it. But, this is also an interesting way to say that. Okay, so f operated onto A gives B. So here, so this is also important that we must learn that how to correctly read mathematics actually. All right. So I can say that G composition f operated onto A, where A is some point here, is equal to operate f onto A. So if A is from A, where is going to be f of A? So the f of A is going to be B, in B. Agree? So if A is from A, the f of A is going to be in B. And B is the domain of G. So I can also operate G onto this f of A. Right? So A is from A, I operated f onto A, so I'm gonna go in B, which is the domain of G, and now I can operate G onto that, what do you call, output, f of A, okay? So this is G composition, f of A is going to be an element in, what do you call, C actually. So that's my definition for the composition of A actually, the composition of the functions G and, what do you call, F. समझ आ रही है बात? Does F composition G make sense? Does F composition G make sense? So here's the thing. So G is a map from B to C. So if I have to apply F composition G onto, what do you call, some B, then, and I define this in the same manner, f of G of B, then does this expression make sense?
Yes.
The answer is no actually. Why? Think about it. The domain of f is A actually. So the f only recognizes or takes the inputs from A. But if you are taking G and operated onto an element in B, all right, so the answer that you're going to get is going to be an element in C. So now I am operating my f onto an element in C actually. The question is, can I apply f onto the C? The answer is not necessarily actually. because maybe the C and A are two different sets actually. समझ आ रही है बात? ठीक है भाई, ऐसा तो नहीं है ना कि you have a function from say z to z, ठीक है, like f of x equal to what do you call 2x, right? And now you substitute f of 1 upon 2. What would be the output? You're gonna say it is silly to ask this question. Why? Because 1 upon 2 is not in the domain of z. It is not an element in what do you call z. So how can I apply f onto the 1 upon 2? So in order to apply f onto some element, that element must be the element of the domain actually, because otherwise the f is not going to recognize actually. All right, you want to print some pages. Okay, the printer only recognizes the pages actually, the special kind of pages, but you can't put anything else into the printer actually, and you can't put a piece of cloth actually and the printer is going to print out. All right, the piece of cloth ko the printer recognize nahi karega. It's not going to recognize what do you call the piece of cloth actually. All right, so every machine has a input actually. Hello, वासला तुम्हारे क्लास में है, तुम्हारा गला है क्लास, ठीक है? Every machine has certain what do you call set of inputs, ठीक है? So you have to also recognize this is not a well-defined way to ask that. Okay, f is a function from z to z, but now you want to apply f onto 1 upon 2. F to पहचानेगा ही नहीं. F is not going to give you any output. This is nonsense, right? So if g is a function from b to c, then g of b is an element in c. Can I apply f onto an element of c? The answer is not necessarily. Why? Because the domain of f is a. So if f is a map from a to b and g is a map from b to c, then only g composition f makes sense. F composition g does not necessarily make sense actually. Okay, but you don't care about this in calculus actually, because in calculus f is a map from R to R and G is also map from R to R. The all sets are same actually. So there is no trouble actually if you want to compute G composition F or F composition G. ठीक है? वहाँ there is no trouble in calculating it. But if the functions have different sets actually, it's defined on different sets, then you can't just always take G composition F or F composition G actually. You have to really see very well that okay, do the expression, this expression makes sense actually. So it makes sense if F is a map from A to B and G is a map from B to C, because if you pick an A from A and apply F onto it, this is going to be an element in B and B is the domain of the G. So now you can apply G onto it and get an element in C. So the G of composition F operated onto A is an element in C. भाई ये बात समझ आई है?
Yes, sir.
जी सर.
So this is important actually. ठीक है? So ऐसा नहीं है कि बस कोलाड़ा चला दे भाई, बस ठीक है कर दो composition. So you have to be very careful and when you are calculating what do you call the composition. So Baki, you know that okay, if G is a function from R to R, and F is also a function from R to R, say G has a definition, say G of x equal to 2x plus 1 and F of x equal to what do you call, say 1 over x square plus 2, then what would be G composition F operated onto X? क्या होगा? So take your F operated onto X, okay, and then substitute this into G actually. So what would be the output? So G is doing what? G is, if taking any input, in other words, if I substitute Bablu into the G, I'm gonna get 2 times of the Bablu plus 1, right? So if I'm substituting f of x into the G, so I'm gonna get 2 times of f of x plus 1 actually. But what is my f of x? So f of x is 2 times of 1 over x squared plus 2 plus 1. And now it is same as 2 over x squared plus 2 plus 1 actually. And if you know, that's really the G composition f actually. But since the domains and codomains in the functions are same, so you can also calculate f composition G. In other words, f of G of x. So what is f is doing with the input? It's doing it 1 over that input square plus 2, right? So you can say that this is going to be same as 1 over G of x square plus 2. But what is G of x? So G of x is 1 over 2x plus 1 square plus 2. So that is really what do you call is your f composition G of x. And you can readily see that even if, you know, if even if f and even if there is a no trouble of domains and codomains, f composition G is not necessarily equal to G composition f. Like these two functions are different functions, this and this. They are two different functions. They are not the same thing actually. ठीक है जी, समझ आ रही है बात?
Yes, sir.
So I can conclude from it that G composition F is not equal to F composition G actually. How about now? How about now I compose. By the way, imagine f is a function from A to B, and I have an identity function. Who remembers the identity function? Who remembers the identity function? So identity of A is a map from A to A. And what is the definition of it? That the identity function operated onto some x gives the same x back actually.
Yes, sir.
See, that's what is really. So if f is a function from A to B and identity function is from A to A, which is, you know, of the function is going to make sense? Identity composition F or F composition identity of A? Which is going to make sense? So see, so keep in view, if F is a function from A to B and G is a function from B to C, then G composition F makes sense from A to C, right? Now, F is a function from A to B and identity is a function from A to A. So F is going to do what? So if I want to compute identity composition F operated onto some A, the output is going to be what? Identity function operated onto some F of A, right? But what is F of A? Where is this element? कोई बताएगा?
B.
B में. So can I apply identity of A onto an element of B?
No, sir.
No, sir.
No, I can't apply. So this does not make sense. This will not recognize f of A. ठीक है? वो कह देगा सिस्टम एरर आ गई है भाई. ठीक है? You have आपने जो है वो you know, so you want to get some, what do you call, sugar cane juice, but you have put something else in that sugar cane juice machine actually, so it's not going to recognize that that's some other thing actually. Are you getting the point? Okay, so how about F composition I operated onto A? Would that make sense? The answer is
Yes,
that
sir.
yes, this is going to make sense actually, because, and what would be the output? That okay, F operated onto identity of A, and identity of A is what?
Yes, sir.
So it's A, so you're gonna get F of A. So you have that F composed with identity of A operated onto A is equal to A for all A in A, right? What you can conclude from here? I have two functions. One function is F composition identity of A. The other function is F, and they agree with each other onto the entire domain. So what are you gonna say? You're gonna say both functions are equal, because this is what is really the definition of equality of the function actually. Are you समझ? हाँ भाई, if you
सर ये
compose
दोबारा बता दें.
if you compose a function, देखे ना, हमने एक theorem prove किया था. We proved one theorem. If you have book with you, we proved one theorem previously in the same chapter, that two functions f and g are equal if and only if f of x equal to g of x for all x from the domain actually. Okay? If two functions are equal, if they agree with each other onto the entire domain. Now I have one function which is f composition identity of A, and one function which is f actually, and their outputs are equal to each other. Do you agree that their outputs are equal to each other? We just calculated actually. F composition I of
Yes,
A
sir.
turns out to be equal to f of A for all A in A. Hence,
Yes, sir.
I can say that F composition identity of A is equal to, equal to F actually, right? So you compose any function with identity, you get the same function back actually. So maybe the identity is behaving like a multiplicative identity. 2 times 1 is 2. So you can treat this A is really an identity. Okay. What? How about, okay, so A composition F does not make sense actually. How about if I say that I take the identity function of the set B and compose it with F actually? Would that make sense now? The identity function of the B is a map from B
No,
to
sir.
B. B to B.
Mm,
Would that make sense now?
yes, sir.
This would make sense. Why? Because the
No, sir, because
identity function of B is operated onto F of A. So F is a map from A to B. An identity map is a map from B to B. So F is going to throw the A into what? The set B. But I can operate and the domain of the identity function of the set B is equal to what? B, right? So therefore I can operate identity function of B onto F of A. But what would be the output?
F of A.
f of a, because whatever identity function swallows, it just spits out the same thing actually.
Yes, sir.
Okay. And this is true also for all a in a. So what does this show? This shows that the identity function composed with f is equal to f itself actually. But the identity function of b. Okay, so from right, if you want to compose the identity function of the domain, and from left, if you want to compose the identity function of the codomain actually. ठीक है जी, समझ आ रही है बात? But interestingly, both identity functions are
Yes, sir.
like behaving like the number one actually. That okay, you take any number and multiply it with one, you get the same function one. ठीक है? By the way, now we know, so here's an interesting thing. I know about one actually, that if I multiply the 2 with its reciprocal, I get a 1. Yeah, take it from left or right, I always get what do you call 1, right? So this is 2 and this is inverse of the 2. जी
सर ये जो हम लिखते हैं ना सर, अगर 2 पे पावर सर -1 है तो उसे 1/2 लिखते हैं सर, ये इसका मल्टीप्लिकेटिव इनवर्स होता है, लेकिन सर ये इसे शो इस तरह क्यों करते हैं सर 1/2?
अरे you लिख सकते हैं ना, देखें 2 पावर -1 अगर है तो you can write this as 2 power 0 minus 1 and you can write this as 2 power 0 or 2 power 1. So you have the 1/2, so you can write it. So इसमें तो कोई प्रॉब्लम नहीं है. समझ आया? So if you have 2 power -1, you can write it as 1/2.
Yes sir.
ठीक है. Anyway, so my point is this, that how about now I use the same intuition. I have a function f from a to b, and I have the function f inverse that is from b to a. Question, what if I compose f with f inverse from right? What if I compose f inverse, with f actually? By the way, f inverse of f, this is going to be mapped from where to where? Someone is going to tell me?
From B to A.
No. F inverse is going to send me from B to A, and then f is going to send me from A to B.
A to B.
So the map overall is from B to
A to A, sir. B to
B.
B to B. Okay, and f inverse is f composition of this is going to be A to A. ठीक है जी. And now let's see what interesting result we get. So it's like here I get 2 multiplied by 1/2 1, like identity. So am I going to get something similar, that if I compose f with its inverse or f inverse with its, what do you call? So am I going to get some identity? The answer is yes, actually. You still get the identity. You have the similar intuition. Kaise? So here's the thing. Let's take that f composition, f inverse, and let's operate it onto some b. Okay? Where b is an element in b. So this is going to be same as f of f inverse of b. Okay? F of f inverse of b. So here is the thing. I want to write the output, that what would be the output here. I don't know yet, but I want to write an output. So let's think about that. What would be the output? So b is from b. Where is going to be f inverse of b? कहाँ होगा? अगर b में से तो where is going to be f inverse of b? So see the domain. So it's going to be in A.
A.
So if it is in A, so it means that it must be equal to some A. By A में है ना? F inverse
Yes,
of
sir.
B is in
यस
A,
सर,
so
यस
it
सर,
must be
कह
equal
सकते
to
हो.
some A. But if F inverse of B is equal to A, that means that F of A is equal to B. है क्या नहीं?
यस सर, क्यों? यस सर.
ठीक है, that's what we proved in our previous theorem actually. Why? Or we use this as a definition. Now here's the thing. F operated onto F inverse of B, and the F inverse of B is A, so I can substitute A here. But F of A is what? It's B. You know, F inverse of B is F of A because F inverse of B is A, but we know that F of A is B, so therefore F of A must be B. So what we got? So we got an interesting conclusion. So when I'm substituting F into F inverse, and I'm substituting any B into it, it is returning B to me. It's returning the same number to me actually, the same object to me. But this is the same property that you have in the identity of B, B as well actually. ऐसे ही है ना? Like this property is also there in the identity of B. है भाई? ये property तो identity में होती है ना, identity भी यही करती है ना कि that okay if you substitute B, it spits out B actually. ठीक है? So this is true
Yes, sir.
for all B in B. So no matter what B you choose, F inverse of F is going to spit out B, and identity of B is also going to spit out B for all B. Hence, what you can say, I can say that F composition F inverse is equal to the identity of B. So this is what something similar you have. That composition is really like behaving multiplication actually, isn't it? Not exactly like multiplication. Okay? Not exactly like multiplication, but yes, something close to it. Okay, so F composition F inverse is B. Now, how about if I want to compute, say, F composition F inverse? No. F inverse composition F. Okay, so to what I must apply now? I must apply it onto some A now, because the F inverse composition F is a function from A to A. So this means F inverse of so it would be equal to F of A. ऐसा ही है. But F of A is B. So I can substitute F inverse of B. So this is going to be F inverse of B. But what is F inverse of B?
A.
It's A. So here's another interesting thing, that F inverse composition F is an interesting function. When I'm substituting A into it spits out A. And this is true for all A, no matter what A you take. Okay? So what does it mean? It means that, but I know another function which have the same property. And which is that function? The identity of A. That if you substitute any A into the identity of A, it spits out the same A. So this means that these two things are equal for all A in A. And hence I can conclude that F inverse composition F is equal to the identity of A. Okay? So if F is a map from A to B and F inverse is a map from B to A, okay, then F composition F inverse is going to be identity on B, and F inverse composition F is also going to be and always going to be an identity on what do you call A actually. समझ आ रही है बात?
Yes, sir.
ठीक है. And what if, so here's the thing, what if f is a function say from R to R actually? ठीक है. R या ये कहेंगे what if a function is from A to A, then what would be f composition f inverse is going to be identity of A, and what is going to be f inverse composition f is going to be again identity of A. So in this case all three are equal to each other. ठीक है ना, क्योंकि यहाँ पर domain और co-domain are the same actually, they are not different, so therefore you know they are going to, what do you call, agree with each other. ठीक है, क्योंकि A और B same है इस केस में, so therefore you know f inverse is really the right inverse and left inverse actually. So are you getting a little bit of
Yes, sir.
Yes,
this? Good. Let me write a final thing and then maybe I end the discussion. ठीक है, really the final thing. let's prove an interesting theorem actually. We will see some of the interesting consequences of all this stuff that we have learned in our next class. Really the exciting consequences. And probably the next class would be the last class actually. Okay. And I would suggest actually that if you can have this next class maybe within this week actually, then you will have enough time for preparation actually. इसी week में ले लें class तो बेहतर होगा, otherwise we can do it on Wednesday next week. What do you say?
sir.
Sir,
इसी week हो.
इसी week कर
इसी
दें.
week बड़ा दिन है.
Yes, sir.
ठीक है, चले देख लें, आपस में कर दें decide and let me know. ठीक. Okay. So first कर दें, you have a function from G from A to B, and f is a function from B to C. ठीक है. And I know about both of these functions, that both of these functions are injective actually. ठीक है, so they are 1 1, that is they are 1 1. ठीक है. Then which is going to make sense, f composition G or G composition f? सोचें जरा.
A to C. G of S, sir.
Maybe both.
Both will make sense. So see,
Maybe.
so not
G of
maybe.
S.
Think about it. F composition G. So G is sending me from B to C, and F is sending me from, oh no, sorry. G is sending me from A to B, and then F is sending me from B to C. The answer is yes, actually. So the map is going to be from A to C. How about G composition F? I'm going to say this does not make sense actually. Why? Because
Sir,
F is JJ.
Yes, sir.
F
G
is
of S is
Yes, sir.
ठीक है ना, F is going to send me from B to C, but I can't operate G onto the elements of C because मुझे नहीं पता
Yes, sir.
कि C is a part of the domain or not actually. ठीक है, so the only F composition G makes sense. So it's not difficult to, you know, realize. So imagine I have a function, two functions, G, one function G, which is from A to B, and F from B to C. And I want to have F composition G, which is going to be a map from A into C. My claim is that this is also one.
सर सर इसमें G of F पॉसिबल नहीं है क्योंकि G A से B तक डिफाइन है और F B से C तक है.
हाँ ठीक है ना, G of F, G composition F possible नहीं, but F composition G possible. ठीक है.
सर अगर F B to A होता तो फिर possible होता।
फिर पॉसिबल होता। यस यस यू आर राइट, ठीक है, यू आर राइट। या ये होता, सो आर अनदर, यू कैन हैव अनदर थिंग एक्चुअली, ठीक है, दैट के इफ आई कुड नो दैट सी इज अ सबसेट ऑफ ए, ये भी पता होता,
Yes sir.
then it would still make sense actually, yes, that you know, uh, because you know the C, the elements of C are the parts of, what do you call, the domain actually. तब भी वो G composition F would make sense. Anyway, so my point is not here. So like these are the small things that we should always reflect actually, ठीक है, when you are doing a bit of sophisticated mathematics, ठीक है, when you are doing in calculus and all this, probably you don't have to worry about all this because everything is real numbers. Set A is real number, B is real number, C is real numbers, so there is no problem actually, ठीक है. But if you are talking about some other functions which have different domains, then you have to always have a look actually that which expression makes sense. So my point is here that I have two functions which are 1 1, and I want to show that their composition is also 1 1 actually. Okay, so this is what my claim is, that if you have two functions which are 1 1, then their composition is also 1 1. So how can I prove that this composition is 1 1? So what should I do? How can I prove that if you give me a function h actually, okay, how can I prove that this function h is 1 1? So I will pick two elements from the domain, right? And I'll equate them, h of a equal to h of a prime. And then I'll try to prove that, can I prove that a is equal to a prime? So if I can prove this, then h would be 1 1. Agreed? ऐसे ही करते हैं ना?
Yes, sir.
Okay. So let's, now what is the domain of F composition G? It's a actually. So let's pick some element from A. So let's pick say A and A prime from A such that their outputs are equal actually. F composition G operated onto A is equal to F composition G operated onto A prime. Okay. Now, how can I write it? Can I write this as F of G of A? So F operated onto G of A and F operated onto G of A prime. ठीक है?
Yes sir.
Now, do I know something about F? I know F is 1 1. Okay, I know F is 1 1. So F already has this property. In other words, if F is operating onto some B and F is operating onto another B prime, then B must be equal to B prime because F is 1 1, right? ऐसा ही होगा.
Yes, sir.
अब if F of G of A is equal to F of G of A prime, so what would be the output? What would be the implication?
G of A.
Yes, the inputs are equal actually. G of A equal to G of A prime because F is 1 1. Okay? So, you know, forget about what is written inside. Okay? So it's like, okay, if F of anything is equal to F of, you know, something else, then these two things are equal. Anything is equal to something else. Okay? No matter what inside is, doesn't matter. Okay? Now I know that G of A is equal to G of A prime. So can I say something interesting?
Yes sir.
What it would be?
A equals to A inverse. Or A equals to A prime.
A prime actually. It's not inverse, but prime. Okay. Why? Because G is 1 1. Because G is 1 1. So from where I started? I started from here that F composition G of A equal to F composition G of F prime. Then from the property of F is 1 1 and G is 1 1, I proved that A is equal to A prime. So what does this shows? This shows that F composition G is also 1 1 actually. ठीक है? That's precisely what you needed to show. ठीक है जी?
Yes, sir.
चले अब if you have this for 1 1, then you can also say what would be am I going to have the same for onto? So if I write another theorem, a quick theorem, and I say that, say the G, if G from A to B and F from B to C are onto, then F composition G, which is the map from A to C, is also onto. ठीक है? So help me out in proving it. How should I prove it? I want to prove that F composition G of C is onto. So what should be my first step actually? What should I do in order to prove F composition G onto? Keep in view, let me recall the criteria to prove onto. That if you want to prove that H is some map from some set to some X to Y, ठीक है?
F of A is equal to A prime.
F of A equal to B prime नहीं precisely बताएं. So H is onto if and only if what happens for all Y in codomain, there is an element in domain, ठीक है? Such that H of X equal to Y. तो ये है पूरी statement. For every element in codomain, there is an element in domain such that H of X equal to Y. So now I want to prove that F composition G is onto from A to C. ठीक है? तो क्या करना चाहिए? So I need to show, we need to show, let's write it clearly. We need to show that for every C in C, there is an A in domain such that F composition G operated onto A should give me, what do you call, C actually, this small c. ठीक है? ऐसा ही होना चाहिए ना भाई?
Yes, sir.
Good.
Yes, sir.
So how to do it? So help me out. What should I do? So let's pick, I have to show this. Let us pick a C from C actually. Now I don't know that whether F composition G is onto or not, but I know that F is onto. है क्या नहीं? F का तो पता है ना मुझे ये onto.
Yes, sir.
So since F is onto, what you can conclude? Since F is onto, so
F of B.
there is a B in the domain of F such that F of B is equal to, what do you call, C actually. है क्या नहीं? है भाई?
Yes, sir.
Good. And now you got a B in B. But do you know something about anything interesting about an element in B? इसका क्या करें? keep in view the onto-ness of G. Okay, G भी तो onto है ना. So if it is onto, then for every B here there is an element A such that G of A equal to B. होना चाहिए.
Yes, sir.
ठीक है.
Yes, sir.
Now B, as B is from B, so and since G is onto, so there exists an A in A such that G of A is equal to B. ठीक है मेरे भाई. Now using this and this, can I conclude this actually? Can someone help me out? That how can I deduce this guy, this statement from this statement and this statement actually? क्या मैं ऐसा करूं कि जो ऊपर वाली statement है वो follow कर दे? You know, just think from this perspective.
सर f of g of a कर लेंगे और क्योंकि g of a बराबर है b के और ऊपर भी.
Good. So one trick that you can do is that take this b, the value of b, and substitute it here. कर सकते हैं ना? ठीक है?
Yes, sir.
So f of b is c and g of a is b. So hence I can say that f of b, which is going to be f of g of a. ठीक है? So the f of b is c. f of b c है, लिहाजा f of g of a c है. So this means that is, I can rewrite this, that f composition g operated onto a is going to be some c. ऐसे ही है. So that really shows that f composition g is really onto as well. Okay, so it's the, so you saw the trick actually, that okay, why, you know, the composition is onto. So we used the onto-ness of the both f and g. So here we use the onto-ness of both f and what do you call g and f, and here you have used the onto-ness of f and g, right?
Yes, sir.
What would be the natural corollary to this result? So if G is 1, if G is 1, 1 and F is 1, 1, then F composition G is 1, 1. Now, if G is onto, F is onto, F composition G is onto. So what would be the natural corollary? The natural corollary is that if I say that the G is 1, 1, I don't need to prove it. I don't need to prove it, that if G from A to B is 1, 1 and onto, and okay, no, let's write it in this manner. Can be F and G both are 1, 1 and onto, then their composition is also 1, 1 and onto. है क्या नहीं?
Yes, sir.
Yes, sir.
So if G composition, G is from A to B and F from B to C are onto, are 1, 1 and onto, then F composition G from A to C is also 1, 1 and onto. ठीक है? है क्या नहीं भाई?
मतलब
जी
सर
जी जी
हम कंपोजिशन के भी इन्वर्स निकाल सकते हैं.
बिल्कुल, exactly. This is an interesting question. That's the next interesting question that you can ask actually. that what would be the inverse of the composition? So any guess for it? The inverse of the composition, any guess for it? कोई guess करें, तुक्का लगाएं, क्या होना चाहिए?
सेम होगा.
सेम होगा?
मतलब 1 1 2
नहीं 1 1 and 2 है, मगर इनवर्स क्या होगा?
inverse G of
Can,
f of
can I write the
equal to A.
inverse of the composition in the terms of composition of inverses actually?
शायद G inverse F inverse हो.
Chale, that's a good, you know, what do you call attempt actually. ठीक है जी, let's think of G inverse and F inverse. ठीक है? Now let's see that whether this makes sense or not. F is from where to where?
A to B.
B to C.
नहीं, A to C.
F inverse is going to be from where to where?
C to A. B
Maybe
to
C
B.
to C to B.
C to B. C
C
to
to
C to
B.
B. ठीक है? G is from where to where?
A to B.
A to B.
So the G so the G is going to be from where to where? G inverse is going to be from where to where?
B to A.
B to A.
B to A. So can you compose G inverse with F inverse? Now think about it. Can you compose G inverse with F inverse? So F inverse is taking you from C
Yes,
to
sir.
B.
G
नहीं एक हमने गलती कर दी बड़ी सीरियस. यहाँ F composition G है. नहीं F composition G है. मैं यहाँ how can I write G composition F here? ठीक है? So let's rethink actually about this. ठीक है?
Yes, sir.
हमें F composition G लिखना चाहिए ना. But we can still think on the same suggestion that was given to us actually, that के भाई F composition G का inverse should be F inverse composition G inverse actually. You know, before saying that, okay, before checking that whether this is true or not, first let's check that whether this makes sense or not actually. So G inverse is a map from B to A, and F inverse is map from C to B. Does this make sense? So G inverse is sending you from B to A, and F inverse is sending you from C to B. Does this make sense?
No, sir.
No, it doesn't make sense. It doesn't make sense actually. So इसका मतलब ये है कि ये तो इसका inverse हो ही नहीं सकता. This can't be the inverse of it. ठीक है? This can't be the inverse of it because like this function does not make sense in the first place actually. So what could be the other potential actually?
So the first one?
Yes, the first one नहीं बल्कि like this one actually, the G inverse composition F inverse. ठीक है?
Yes, sir.
So if you want to find
Okay.
if
yes,
you
sir.
want to find
Got
the
it.
inverse of the composition, then find the F inverse, find the G inverse, and then compose them.
सर बेसिकली F inverse की सेंस नहीं बना रहा था ना.
F inverse क्या नहीं
सर
बना
जो
रहा था?
फर्स्ट उसका सर F inverse of G of G F inverse of G inverse वो वाला सेंस क्यों नहीं बना रहा था, वो समझ में नहीं आया.
नहीं देखो ना, वो इसलिए नहीं बना रहा because think about it. If G is from A to B, G inverse is going to be from B to A, right?
सही है सर.
And F inverse is going to send me from where to where? C to B. So can I apply F inverse onto the elements of C? The answer is no, it doesn't make sense. Okay? So therefore, कम से कम F composition G का inverse cannot be F inverse composition G inverse because ये तो function ही नहीं है. And we know that F composition G का inverse should be a function because F composition G is 1, 1 and 2. So this is really a choice, but I don't know that whether this is really the inverse of it or not. So verify it. ठीक है, ये आपने खुद वेरीफाई करना है. You have to prove the equality of these two functions. You have to prove that f composition g का inverse, this function is equal to g inverse composition f inverse. Prove it for yourself actually. ठीक है, you will see that this would be true.